All right, hello everyone. Today we're carrying on with the Physical Sciences DBE November 2023 question paper for grade 12. This is paper 2, so chemistry. Questions 1 through 6 have been done in previous videos. In this video, we're going to take a look at the monster question that is question number 7. This is a acids and bases type question. And it always gets a little bit scary when you see very short questions like this carrying like 8 marks and again 5 marks. So there's a lot of calculation steps in this question, but we're going to take it one step at a time and hopefully get through this question easily. All right, so let's first read the preamble information before we get down to the questions. To identify metal M in an unknown metal carbonate, the following procedure is carried out. So first, let's just highlight the important information. 0.198 grams of impure. This is very important that this is impure, MCO3. This is also a bit of a clue as to this metal because we know that the carbonate ion exists as CO3 2 minus. If our formula is MCO3, this implies that the metal M is a 2 plus ion. So group 2, perhaps. Something in group 2. It's just important to like just have this in mind. But yeah, okay. So is reacted with 25 milliliters of 0.4 molar nitric acid, HNO3, yeah? So that's step 1. So we just take our unknown compound and react it with some acid. There's an excess of acid, okay? So this is important. Excess of HNO3 is neutralized, and it takes this much of barium hydroxide to neutralize it. Okay, so we've already got quite a bit of information here to get us started, and they also give us the equations. And here's another clue that our compound is 2 plus. Our metal is 2 plus because again we know that the nitrate ion exists as NO3 minus. So if it's M NO3 2, right, this 2 implies that our metal is 2 plus once again. So yeah, for sure we know our metal is 2 plus, and it reacts with 2. It takes 2 stoichiometric units of HNO3 to react with it as well. So that's another clue, this 2 here. All right, so reacting it with the acid, we get a nitrate as expected. We get carbon dioxide gas because we have a carbonate and water. This makes sense. And then in the second step, any excess acid from here, unreacted acid, we neutralize it with barium hydroxide and we get barium nitrate and water as well, as expected. All right, so let's now get into the questions. So the first question is simply define a strong base. So there are a couple of ways to phrase this, but however you choose to phrase it, you need to basically say ionizes or dissociates, ionizes completely. So the key word is completely. And then, in water. So whether you choose to say dissociates or ionizes, the key word here is completely and in water. I know some other definitions you may like to use is things like has a low pH, reacts uh, in a certain way. Whilst those aren't wrong, those aren't the textbook definition of a strong base. This is the simplest definition, and usually simplest is best to score your 2 marks. So if you go on and give a bit of a more complicated definition of saying a strong base has a pH of 14 or something like that, that isn't technically incorrect, but it's there are other things that can also have a pH like that. So it's just easier to say it's something that completely ionizes. It's the easiest definition. So always just go for the easiest definition. Don't complicate things. But yeah, all right. So moving on. Calculate. Just clear my board. Calculate the number of moles of barium hydroxide that reacted with excess HNO3. So, all right. Here we just need to remember our simple equation that uh, concentration equals moles over volume. And since we want to calculate the moles in this case, we have moles equals concentration times volume. And this information is given to us over here that the excess HNO3 reacted with 20 milliliters and 0.15 molar barium hydroxide. So we just substitute these numbers in. You must remember that because the concentration is given in decimeters, you have to convert your centimeters cubed into liters or decimeters. It's the same thing. So you have to divide by 1,000 to have your correct volume. So the concentration is 0.15 times dividing 20 by 1,000, we get 0.02, and then we get our final answer of 0.003 moles. Okay, so this is important. So why don't we just rewrite the answer down here? 0.003 moles. Just a couple of comments when doing these calculations. Each step of the calculation is marked. As you can see, the question is 3 marks. So you'll get a mark for choosing the correct equation, substituting the correct values, and giving the correct answer. So in case you get the wrong answer, you just want to write down all the steps. You might score part marks elsewhere. You always want to include units, and you want to include the correct number of significant figures in your answer. Yeah, so technically, maybe for this question, the correct number of significant figures would actually be 0.0030 molar, because we have 2 significant figures initially in the numbers we substitute in. So this is technically more correct, but yeah, just some things to think about. You don't want to lose a mark because you forgot to put the units, or you did the calculation incorrectly and you didn't show your steps. So you lose a mark because maybe you just wrote the answer instead of showing the steps here. But yeah, these are just some things to keep in mind when doing these calculations. Okay. Now, the second part is a bit more tricky. So they want us to find the pH of the solution after step 1. So another way of
I'll be there. I will be there.
So another way of interpreting this question is basically it's asking how much HNO3 was left over after the reaction. That's that's basically how you need to interpret this question. So we got to work backwards. So we've calculated the moles of barium hydroxide used in this step. Um, so we can then use that to calculate some information about this, which will then tell us exactly how much was left over here, and then use it to calculate the pH after step one. So we're kind of working backwards, all right? So let's see if we can make some sense of this question. So the first thing is, let's calculate the moles of NHO3 that reacted with the barium hydroxide that we just calculated. So we can see in this equation that the ratio is 1:2. So there's twice as many moles that have reacted compared to what we just calculated. So the first step would be the moles of HNO3 in step 2. So maybe, I don't know, you can just put like a subscript 2 there, or whatever makes sense to you to just know what we're calculating. So this is the moles in step 2, equals twice the amount of moles of the barium hydroxide, OH2. So this basically just equals 2 times 0.003, which, not even using a calculator, just using your head, that's 0.006. Okay, so that's the first thing we can do. So now that we have this, we know the volume and concentration of the nitric acid. So let's try and figure out how many moles of nitric acid there were initially. So there's a few ways you could do this. I'm choosing to first calculate, using this, how many moles of nitric acid there were in the beginning before any reactions. So maybe I can put this on top. So we can say moles of HNO3, and then I'll just put an I for initially, equals concentration times volume. Our concentration is 0.4, and our volume is 0.025. Calculating this out, yeah, so let's just use a calculator real quick. 0.4 times 0.025. This is 0.01 moles. So actually, this step might not be necessary. We've just done this calculation, but it might we might just keep this for the last question, because I'm actually realizing that you don't need this. If you know the amount of moles left over after step one of acid, you basically just need to calculate uh, its concentration. So yeah, so we got to calculate its concentration after step one. And to do that, what we need to realize is that there's there's actually 45 milliliters of liquid. So basically the acid is now diluted after step one, because you generate water, and you generate some aqueous components. The acid becomes dilute. So we know the moles at the end of step one that are left over. If we know the new volume, we can then simply calculate the new concentration, because there is definitely a drop in concentration. All right. So yeah. So carrying on. So okay. So we did this. We did this step up here, not for nothing. It'll be useful in the next question. What we need to realize is that the concentration of hydronium ions is equal to the concentration of HNO3, or not concentration. Let's just say uh, the moles of HNO3 over the total volume in the reaction. So definitely, yeah, and it's 45 because you have 20 and then you have 25, then you add 20 again. So before the reaction actually happens, you have a total volume of about 45 cm3. So substituting in here, we have 0.006 over 0.045, and then we get 0.13 as the concentration before the second reaction. Now that we know that concentration, we can calculate the pH. So you just have to remember that the formula for pH is pH equals negative log. This log is base 10. Um, so you can put it in like that on your calculator. If you just use the log function, it automatically goes base 10, then H3O plus, substituting values in, negative log 10, 0.13, and this gives a pH of about 0.89. So very acidic, very, very acidic. Yeah, so there are a couple of different ways of calculating this. I think the most difficult part is definitely realizing that the volume is actually 0.045. And you get that from just realizing that we're going to add 25 milliliters of some liquid and then 20 again to get the 45. And you just have to realize that this is the pH before the barium actually reacts. So before this reaction happens, but it's the pH when all the liquid is in one reaction flask. So I think that's the trickiest part. But yeah, so there's about three sections to this question, three calculations you have to make. First is just figuring out the uh, the moles of HNO3 left over, and then figuring out the new concentration of hydronium ions, right, with the new volume, and then doing the log calculation to get the actual pH. And that gets you your 5 marks. So it's a really big question. There's three steps to it. The tricky part is figuring out the new volume of all your solution. Um, I think many students would make the mistake of calculating the new volume with 25 and not 45. And yeah, you might still get part marks if you do the rest of the question correctly, but you won't get full marks. This is definitely the trick to the question. Okay, now let's go on to question 7.3. So the percentage purity of MCO3 solid, so our unknown metal carbonate, in the sample is 85%. Identify metal M. Whew. Okay, so let's uh, let's come up with let's do a bit of thinking here for a second and come up with how we're going to do this. So 85%. So this is the new piece of information we're given. It's 85% pure. Um, so what we need to realize is that that means that of this uh, 0.198 grams, only 85% of it is actually the metal carbonate. So we know exactly how much acid from the previous questions we've done. We know how much acid reacted. So we're going to make an assumption here, a necessary assumption. We're going to assume that the acid only reacts with um, the metal carbonate, and it doesn't react with the other 15% impurities. So this is an important assumption because it gives us a way of trying to figure out what the metal carbonate is. So we have to make this assumption first before we can carry on with the question. Okay, so step one is basically what I had done previously, which is calculate the amount of HNO3 initially. So the amount of moles of acid that we start with, which is 0.01 moles. Next, we need to figure out how much acid actually reacts. Okay, so how much acid um, actually reacts? And this is simple. So this, we just take the total amount of acid we had initially, which is 0.01 moles, and we subtract it with the amount of acid we had left, right, which is this one. So that's 0.003 moles. And subtracting these two, um, or rather you want to subtract, sorry, so not the 0.03. You want to subtract, you need to figure out this we multiplied by 2. Yeah, see, you got to be careful. The 0.003 is the moles of barium hydroxide, not the acid. So we actually need to multiply this by 2 as we did in the other question. So this is actually 6, not 3. You have to be very careful with these questions. And this gives us 0.004 moles. Okay, so now we know exactly how much acid reacted. Yeah. Now, from our stoichiometry, from our equation, we can see that the ratio of acid to metal carbonate is 2 moles of acid react with 1 mole of metal carbonate. So that basically means that the moles of metal carbonate um, is equal to half the moles of a reacted acid. So we're just going to divide this by 2, multiply by a half, and of course we're going to get this. Okay. Now, uh, they've given us some important information. They've told us that it's 85% pure. So if we want the mass of the metal carbonate, this is the M, mass of the metal carbonate. We basically need to say what is 85% of 0.198 grams. So you can just say 85 over 100 multiplied by that, and you will get 0.168 grams. This is an important step that you just don't use the given mass earlier. You have to calculate the actual mass of metal carbonate. That's why they told us it's 85% pure. Okay, now we have the moles and we have the mass. We can use this equation N equals M over MR in order to calculate the molecular weight of our metal. And we can use that to identify it. So substituting in, let's first make molecular weight the subject of the formula and get myself some space. Okay, so that means it is 0.168 over the moles, which is 0.02. And this gives us roughly 84 grams per mole. But now remember that um, remember that this is for the metal carbonate. So not just the metal alone. So we need to account for this carbon atom and these three oxygen atoms. And the carbonate ion on its own has a molecular mass of roughly 60. So if we want to get the molecular mass of our metal alone, we have to say, so mr of m is basically 84 minus 60, which is roughly 24 grams per mole. And if you go and look on a periodic table, 24 gives us magnesium. And this makes sense because we know magnesium is a group 2 metal. We know that it forms a 2 plus. Yeah, and we basically figured it out. So that's it. On questions like this that have many steps to them, it's always important to try and dissect the question. If it helps, rewrite any useful information on top, write any assumptions down, and then start doing the work. If you lay your work out like this, an examiner might give you extra marks, even if you get the final answer wrong, but you show some decent reasoning and logic, you write down your assumptions, you show all your work, you can still score decent marks, even if you miss the final answer. So it's always important just to like lay it all down, write everything, and double check yourself. Take the time to go through it, make sure each step makes sense, it's logical, and yeah, use your calculator to like go through all the calculations real quick to make sure you're getting the correct numbers and you're not mistyping anything, because it's very easy to lose marks because you accidentally type in the wrong figure or forget a zero on your calculator. Yeah, just as I put down the wrong value here, I forgot to multiply by 2. A mistake like that would result in us getting the wrong final metal. So you have to be really, really careful. But that concludes question 7.